In this video, we want to show that this equality is true. So we're going to start with the left side of the equation. And notice that 3k over 5 pi is raised to the first power. So the way I'm going to simplify this is by having a same root. So currently, 5 pi over 3k is squared and then cube rooted. So the root there is the cube root. So I want 3k over 5 pi to have the same cube root. Well, if I have 3k over 5 pi as a cube root, I need to cube it in order for it to be the same as 3k over 5 pi. So the cube root and the cube are going to cancel, and I'm going to be left with 3k over 5 pi. So therefore, I'm going to write 3k over 5 pi as 3k over 5 pi raised to the 3 over 3 power. Note that when I have a raised to the b over c power, that's the same thing as taking a, raising it to the b power, and then that entire thing raised to the 1 over c power. Which is also equivalent to taking a, raising it to the 1 over c power, and then taking that entire thing and raising it to the b power. I can do this because whenever I raise an exponent to an exponent, I end up multiplying the two exponents. And we know multiplication is commutative. That means if I have 2 times 3, that's the same thing as 3 times 2. So in this case, b times 1 over c is the same thing as 1 over c times b. But for us, we're going to use the first equality. So I'm going to factor out the cube roots. And that leaves us with cubing and squaring the inside. So for 3k over 5 pi, I'm going to take everything and cube it. So that would be 3 cubed, k cubed, and 5 pi cubed, which will be a little more interesting. And then for the 5 pi over 3k, we want to square it first and then cube root it. Right? So then we'll end up having 27k cubed over 125 pi cubed, and then 25 pi squared over 9k squared. So keep in mind, you have to cube and square everything inside the parentheses. For the next piece, whenever we have a raised to the 1 over c power, and we multiply by b times 1 over c power, that's the same thing as multiplying a times b and then taking the 1 over c power. So the way to think about this is they both have in common the root, so you can factor out the root and apply it later. So in our case, we have the same roots, they're cube roots. So we could just take the two insides and then multiply them. So the multiplication is very nice because for the first diagonal, you have 27k cubed over 9k squared. That simplifies to 3k. And for the second diagonal, you have 25 pi squared over 125 pi cubed. And that simplifies to 1 over 5 pi. So you have 3k over 5 pi, all raised to the 1/3 power, which when you raise it to the 1/3 power, that's equivalent to taking the cube root. And this completes the problem.